Our focus is going to be on continuing solving fraction one-step algebraic equations by using inverse operations, reciprocals, and checking my work. So the first part of 2-5, we absolutely did not use reciprocals. We just used inverse operations and checking my work because reciprocals are going to be related to multiplying fractions. So we're going to start with that. So just a little review of what a reciprocal is. So a reciprocal, so when I talk about what a reciprocal is, so it is a term that we use for fractions, and it is going to be where I have two products whose number, when I multiply them, is 1. So a product is going to be 1. So if I have 1/2 times 2 over 1, these two numbers are reciprocal to each other because, again, when we multiply fractions, we multiply the numerators. We just multiply straight across. So it would be 1 times 2 and 2 times 1. So if I back up a step and not just give you the answer of 1, but if I back up a step and do this, it's 2 over 2, which we then simplify into 1. So if when asked what is the reciprocal of 1/2, the reciprocal of 1/2 would be 2. The reciprocal of 2 would be 1/2, because when I multiply these two values together, I get a value of 1. So another way that you can think about a reciprocal is it's going to be the fraction flipped. So if I have 3/8 and I need to multiply by the reciprocal is going to be the flipped fraction. So I flip my numerator and denominator to get the reciprocal. So now my reciprocal of 3/8 is going to be 8/3. Okay, so just keeping that in mind as we get going. In fact, our first problem is going to be 3/8 n equals 15. So in order to get rid of a multiplication relationship, we typically divide. Well, our inverse operation for fractions, and for fractions only, when I have a multiplication relationship, is going to be to multiply by that reciprocal. And again, because I multiply this side by 8/3, I need to multiply this side by 8/3. So in order to do this, I need to make 15 into a fraction. And to make 15 into a fraction, I'm just simply going to put it over 1. Because anytime I put a whole number over 1, that represents 15 wholes. Now I'm going to multiply straight across. But before I multiply straight across, I always want to see if I can cross cancel. So cross canceling, if you remember, is where I take a value and I look at diagonally to see if I can simplify by dividing them by the same factor or by the same number. So 8 and 1, they're already simplified because I can't get any smaller than 1. So 1 goes into 8 times. 15 and 3, I can simplify those. I can cross cancel them out because they share a common factor. The common factor that they share is 3. So this is going to become a 1. This is going to become a 5. This became much easier to multiply now. So now it's 5 times 8, which is going to be 40 over 1, or n equals 40. So again, I have now solved my one-step algebraic equation. I used the inverse operation. When I multiply fractions, the inverse operation is multiplying by the reciprocal. And so I used inverse operations, I used reciprocal. Now I need to go back and check my work. So to go back and check my work, I'm going to go back to my original physical setup and check my work and see what I have. So I have 3/8, and I'm going to set it up this way because, again, my check is about making it easy for me to understand. 3/8 times 40 over 1 is equal to 15. So again, I look, can I cross multiply? Well, 3 and 1 is already simplified as far as they can go. 40 and 8 I can though. 8 goes into 8 one time. 8 goes into 40 5 times. So now I'm going to multiply 3 times 5, which is 15. So I end up with 15 equals 15. So my equation is balanced. And I didn't write it as 15 over 1 because it's understood that 1 times 1 equals 1. Okay, so let's try another one of those multiplication problems. So when I try another one of those multiplication problems, if I have p over 5 equals 8. Okay, I don't want to do that one yet. That's a division equation. Let's keep with multiplication. Let's do, in the did you know how, I'm at number 5, 2/3 r. So 2/3 r equals 6. So I'm going to first look at my operation. The operation that I'm doing is multiplication. The opposite of multiplication in fractions is to multiply by the reciprocal. So if I have 2/3, again, my reciprocal, I'm going to flip my numerator and denominator. So my reciprocal is going to be 3/2. And then I have to multiply this side by 3/2. And then put this over 1 and see if I can cross cancel. 1 and 3 is already simplified, but 6 and 2, they have a common factor. 2 can go into 6, and 2 can go into 2. So 2 goes into 6 3 times, and 2 goes into 1 time. So now my answer is going to be 9. So I have r equals 9. So I'm going to go and I'm going to do my check and see where things end up. So I'm going to do my proof. So I have 2/3. And again, when I do my check, I'm going to do it as 9/1. Keep it in that fraction notation, and it needs to equal 6. So I'm just going to put my 6 over here to see if those equal. All right, look to see if I can cross cancel. 2 and 1, that's already simplified because I have the 1. 9 and 3, I do have a common factor there. My common factor is going to be 3. So 9 divided by 9 is going to be 3. 3 divided by 3 is going to be 1. 2 times 3 is going to be 6. And then 1/1. Remember we talked about on the last problem, 6/1. If I write that in whole number notation, that's a 6. So my equation is balanced. Okay, now let's go back to that division equation. So it's a division equation because, again, this is division notation, right? We talked about one of the 3 division notations. We have the box, which we're familiar with. We have the division symbol, which we're familiar with. But fractions can also be written as division notation. So go back to my problem. P divided by 5 equals 8. To do this, to solve this, I'm still going to multiply by the reciprocal of p over 5. Now, we talked about anytime we have a variable that's by itself has a coefficient of 1. So if I look at this, to multiply it by the to multiply it by the reciprocal, I'm going to multiply it by using my coefficient and my denominator. So it's going to be 5/1. Now, when I do this, we talked about the cross canceling, right? 5 and 5 are going to cancel each other out. The 1 and 1 is going to cancel each other out. And then all I'm left with is that variable. And then on this side, I'm going to multiply it by 5/1 or 40. So P is going to be equal to 40. Now you're probably thinking to yourself, Miss Strong, I could have just multiplied both sides by 5 and found the answer. You're absolutely right. But I wanted you guys to be able to see that the reciprocal of a variable over a number, so written in fraction form, I still multiply it by the reciprocal. And the reciprocal in this case is going to be 5 because my fraction was 1/5. Okay, so let's take a look at another one of those. And if I look at one of those, I'm actually, wow, just going to make one up because you don't have one in the book. So if I have 36n equals, I don't want to do that because I just gave you the answer. So let's do 54. Boy, I'm struggling with this. M divided by, let's do 9 equals 8. So again, I would multiply both sides by the reciprocal. In this case, it would be 9. And I'm left with m equals 72. So I do my check. 72 divided by 9 is going to be equal to 8. So there's my proof that my answer is right. So 8 equals 8. Okay. All right. So hopefully that makes a little bit more sense on how to multiply and divide. Let me go through and do one more division problem just to make sure that you have it. And I'm going to look at number 4. So I have 1/8 k equals 2. So again, to solve this, this is a multiplication. But in fractions, in order to get rid of multiplication, I'm going to use multiplication with the reciprocal. So I'm going to multiply by the reciprocal. These cancel each other out, and I'm left with k. So look to see if I can cross cancel. 2 and 1, 2, 8 and 1. We're simplified as much as we can be. So this is going to be 16. K equals 16. Now I do my proof. So set up my proof to where I have 1/8 times 16 over 1, and that has to equal 2. So again, I can look to see if I can cross cancel. Here I have 1s, here I have 8 and 16. I can cross cancel here. This right here, if I divide by 8 becomes a 2, divide by 8 becomes a 1. 2 times 1 is 2, 1 times 1 is 1, so I can just write it as 2. 2 is equal to 2, so my equation is balanced. So again, remember that when you guys are multiplying, when you have a multiplication relationship with a fraction, you multiply by that reciprocal. You flip your numerator and denominator to get that reciprocal. So you'll end up being able to do cross-canceling to see and then to get the variable by itself.